Look up right now. If you're inside, go to a window. Look at the sky. What do you see? Most people see a void, an endless black ocean of nothingness stretching out forever. You've been told since you were a child that the universe is infinite, that it goes on, without a wall, without an end, without a stop. It feels intuitive, it feels right, but it is wrong. Not just a little wrong, it is fundamentally dangerously wrong. Here is the fact that should keep you awake tonight. If the universe were truly infinite and had existed forever, the night sky would not be dark. It would be white, blindingly white, as bright as the surface of the sun. Every single point in the sky would eventually end on a star, but it's dark. That darkness is a clue. It's a crime scene evidence marker telling us that the infinity you believe in is a lie. So if it's not infinite, does it have an edge? If you flew a spaceship long enough, would you hit a wall? Would you crash into nothing? No. The truth is much weirder than a wall. I found something in the math of topology that suggests our reality is trapped in a shape you wouldn't believe if I just told you. Let me show you. First, we have to break a bad habit. Stop saying the universe. It's lazy. And in physics, lazy gets you the wrong answer. You need to understand that there are actually two universes. There is the global universe, everything that exists. And then there is the observable universe. This distinction is not just vocabulary. It is the walls of your prison cell. Here is the trap. Light has a speed limit. It travels at 300,000 kilometers per second. Fast, sure, but on the scale of the cosmos, it's a snail crawling across a continent. Because the universe has a birthday, about 13.8 billion years ago. Light from objects further away than that hasn't had enough time to reach us yet. It is still on its way. Close your eyes and imagine this. You are standing in the middle of a thick, pitch-black forest. You have a flashlight. That beam of light only reaches 10 feet in front of you. Does the forest end at 10 feet? No. The forest might go on forever, but your reality ends at the edge of that light. That is the observable universe. It is a bubble of information centered on you right now. But wait, your brain is lying to you about the size of the bubble. You might think, okay, the universe is 13.8 billion years old, so the edge is 13.8 billion light years away. Wrong. Because space itself is stretching. While that light was traveling to you for billions of years, the space it was traveling through was expanding like taffy. So the edge isn't 13.8 billion light years away. It's actually about 46 billion light years away. That is the wall. That is the horizon. Everything inside that bubble is the observable universe. We know that part is finite. It has a specific amount of energy, a specific number of atoms, about 1080, and a specific size. But here is the million-dollar question. What is outside the bubble? Is it just more forest? Does the forest go on forever, or does the forest loop back on itself? If you walk in a straight line past the edge of that light, do you keep walking forever, or do you eventually hit the back of your own head? Let's talk about Pac-Man. Remember playing that game? When you move Pac-Man to the right side of the screen, he didn't hit a wall, he didn't crash, he didn't stop, he popped out on the left side. If Pac-Man was a physicist, he would say his universe is infinite. He can travel to the right forever. He never hits a barrier. He never stops moving. But is his universe infinite? No, his universe is a finite box. It just has a weird rule. The edges are connected. This is what physicists call topology. It's the study of shapes, but not the boring kind you learned in high school geometry. This is the geometry of reality itself. Here is the part that makes most people click off. But don't. This is the key. You assume that to be finite, the universe needs an edge, a cliff you can fall off, a wall with a sign that says the end. That is 2D thinking in a 3D world. Think about the Earth. Start walking west. Just keep walking. Will you ever fall off? Will you ever hit a wall that says end of Earth? No. You can walk west forever. Infinite walking. But the Earth is not infinite. It has a finite surface area. It has a specific number of square miles. It is finite, but unbounded. Einstein showed us that space isn't a rigid stage. It's a fabric, and fabrics can bend. If the universe has enough mass, gravity bends space. If it bends it enough, space could curve back onto itself, just like the surface of the Earth. So, if you got in a rocket ship and flew in a perfectly straight line, lasers locked, no turning, for billions and billions of years, you wouldn't hit a wall. You wouldn't enter nothingness. You would eventually see a very familiar planet. You would see Earth. You would arrive at your starting point. You would crash into the back of your own ship. This is called a positive curvature universe, a hypersphere. It means the universe could be a closed loop, a hall of mirrors, a trap. But how do we know if we're in a Pac-Man game or an infinite flat sheet? We have to look for ghosts. Imagine a hallway that never ends. Now delete the hallway. Instead, you are standing in a room made entirely of mirrors. Floor, ceiling, walls. What do you see? You see an infinite number of rooms. You see an infinite number of you. If you look deep into the reflection, thousands of rooms away, you see a tiny version of yourself. But is the room infinite? No, it is one room. The illusion of infinity is created by light bouncing back and forth. Duh. It sounds like philosophy, but it's actually cold, hard geometry. If the universe is finite but wraps around like Pac-Man, then light has had enough time to circle the universe multiple times. That means when we look at a distant galaxy, we might not be seeing a new galaxy. We might be seeing our own galaxy. Wait, think about this. Light takes time to travel. So if you see your own galaxy after the light has circled the universe once, you aren't seeing it as it is now. You are seeing it as it was billions of years ago. You are looking at a ghost. You are looking at the Milky Way when it was a baby. Astronomers have actually looked for this. They call it cosmic topology. They search for repeating patterns in the sky, circles in the cosmic microwave background, the baby picture of the universe, that match up perfectly on opposite sides of the sky. If we found matching circles, it would be the smoking gun. It would prove we live in a hall of mirrors. So far, we haven't found them, but that doesn't mean the universe is infinite. It just means the room is bigger than we thought. Maybe the light hasn't had time to make a full lap yet. Maybe the mirrors are too far away. But let's play devil's advocate. What if the universe is infinite? What if it goes on forever in every direction? That sounds comforting, right? Big open space, freedom. Wrong. An infinite universe is not freedom. It is a nightmare. If the universe is truly infinite, then something terrifying happens to you, specifically to the atoms in your body. Let me show you the math that proves you are not unique. Let's play a game called the copy-paste universe. This is where your intuition fails. You might think infinity just means really big, like a huge sandbox with endless room. No, infinity means everything happens. Everything that is physically possible must happen not once but an infinite number of times. Think AB. Out a deck of cards. If I shuffle it, there are 8 by 1067 possible arrangements. That is a staggeringly huge number, but it is finite. Now imagine I shuffle the deck an infinite number of times. Eventually, I will deal the exact same hand. Eventually, I will deal every possible hand. Now stop looking at cards. Look at the universe. The universe is just a big deck of cards. The cards are quantum particles. Every atom in your body, every electron, every quark is just a card in a specific arrangement. Your brain state, your memories, your eye color, it's all just a pattern of particles. There are only so many ways to arrange particles in a specific volume of space. Physicists have calculated this number. It is huge. It is 1010115. But here is the trick. If the universe is infinite and space goes on forever, then nature has an infinite number of chances to arrange particles. It is like rolling dice forever. Eventually, you will roll snake eyes 1 billion times in a row. So if you travel far enough, about 1029 meters away, you will find a patch of space where the particles are arranged exactly like they are here, exactly like Earth, exactly like you. That person will look like you, talk like you, remember your childhood. But maybe they made one different choice this morning. Maybe they wore a red shirt instead of a blue one. Keep going further. You will find another you and another and another. In an infinite universe, there are infinite versions of you, infinite Earths, infinite histories. This is the monkey problem. If you give a monkey a typewriter and infinite time, he will eventually type Shakespeare. If you give the universe infinite space, it will eventually type you again and again. This destroys the idea of you. It makes you a commodity, a repeated pattern on wallpaper that never ends. Does that sound like reality to you? Or does it sound like a glitch? Most H. Physicists hate this idea. It feels wrong. It feels like a broken calculator. And there is a reason they hate it. Because there is a hard limit built into the fabric of reality that suggests infinity is impossible. A limit so small you can't even see it. You think space is smooth. Like a slide. You can slide down it forever, right? You can zoom in forever. Wrong. Space is not smooth. It is pixelated. Zoom in on your hand. You see skin. Zoom in more cells, more DNA, more atoms, more protons, more quarks. Keep going. Eventually you hit a wall, a fundamental terrifying wall. It is called the Planck length. It is 1.66 times 10 minus 35 m. This is the smallest possible measurement of length in our universe. Anything smaller than this, and physics as we know it completely breaks down. It stops making sense. Think of a video game. Look at Mario. If you zoom in on Mario's face, eventually you see square pixels. You cannot zoom in between the pixels. There is no half pixel. The game engine doesn't allow it. Our universe has a pixel size, the Planck length. So if space is made of discrete chunks, then the universe cannot contain infinite information in a finite volume. This is where the standard model breaks down. If space has a minimum resolution, then there is a maximum amount of information you can pack into any region of space. This is called the Bekenstein bound. It says that a finite volume of space can only hold a finite amount of information, entropy. If you try to pack more information into a region than the Bekenstein bound allows, something catastrophic happens. You create a black hole. But if the universe were truly infinite in every way, infinite resolution, infinite detail, then every single point in space would contain infinite information, and the universe would instantly collapse into a black hole. But it hasn't. We are here. We aren't spaghetti. So the universe cannot be infinitely detailed. It must be pixelated. And if it is pixelated, it suggests something profound about the nature of reality. It suggests the universe is computable, like a simulation, like a program running on a computer with limited memory. It suggests that infinity is just a lazy mathematical trick we use when we don't know the answer. But if the universe isn't infinite, what shape is it? The data is starting to whisper an answer, and it looks like a donut. Let's talk about a torus, or if you prefer, a donut. This is the wildest theory in modern cosmology, and it's not just a stone or a thought. It's based on real data. The cosmic microwave background, or CMBB, is the baby picture of the universe. It is the afterglow of the Big Bang. When we look at it, we expect to see a random distribution of hot and cold spots like static on a TV. And mostly we do. But there is a pattern in the static that shouldn't be there. It's called the axis of evil. No, seriously. Physicists call it that because it threatens everything we know about the cosmos. Imagine you are looking at a soccer ball. If you only see one hexagon, you can't tell the shape of the ball. But if you see enough hexagons, you realize they curve, they connect. The CMBB has patterns. Specifically, the largest hot and cold spots align in a way that suggests the universe has a specific closed shape. If the universe were infinite and flat, these spots should be random. They shouldn't line up, but they do. And the shape that fits the data best, a 3 torus. This is a 4-dimensional donut. Think about the game Asteroids. Remember how if you fly off the top of the screen, you appear at the bottom. And if you fly off the right, you appear on the left. That is a 2 torus. It is a flat surface that wraps around itself like a tube, and then that tube wraps around itself like a donut. If our 3D universe is a 3 torus, it means space is finite but has no edge. You can travel in any direction, up, down, left, right, forward, back, and you will never hit a wall. You will eventually return to where you started. But here is the kicker. In a 3 torus universe, light can take different paths to reach you. Some paths are short, some are long. Some loop around the donut hole, some go through the hole. This means you could look in one direction and see a galaxy as it was 1 billion years ago. Look in another direction and see the same galaxy as it was 5 billion years ago. You would see multiple versions of the same object at different ages. It would be a hall of mirrors, but distorted, twisted. But if the universe is a donut, what is outside the donut? This is the part where your brain breaks. What is outside the donut? What is outside the universe? The answer isn't nothing. The answer is the question makes no sense. Stop asking it. Let me explain why. Imagine you are a 2D stick figure living on the surface of a giant balloon. You can move forward, backward, left, and right. You live in a 2D world. Now, someone asks you, what is outside your world? What happens if you jump up? Up, you ask. What is up? You don't have a word for up. Your entire reality is flat. There is no outside the surface of the balloon. The surface is the universe. Now take a deep breath. You are a 3D creature. You understand length, width, and height, but the universe might be a 4D shape, just like the balloon is a 3D shape. When we ask what is outside the universe, we have a stick figure asking what is up. There is no outside. The universe contains all of space, all of time, all of the dimensions. It doesn't need to be inside anything else. Think of the surface of the Earth again. Is there an edge to the Earth where you fall off into space? No. Is there a center on the surface of the Earth? No. Every point is the sa, me. Is the surface of the Earth infinite? No. But it has no boundary. The universe is exactly like that. It is finite but unbounded. If you travel in a straight line, you eventually come back to where you started. But you never leave the universe because there is no outside to leave into. Space is not a box. It is the stuff inside the box, and the box is the stuff itself. But there is one problem with this idea. We know the universe is expanding. The balloon is getting bigger. So what is it expanding into? Let's blow up a balloon. Draw some dots on it. These are galaxies. As you blow into the balloon, the dots move away from each other. Are they moving? No. The space between them is stretching. This is exactly what is happening to our universe. It is expanding faster than the speed of light. But what is it expanding into? Nothing. It is creating new space as it expands. Think of it like knitting a scarf. You are adding new loops of yarn. The scarf gets longer, but it isn't moving into a pre-existing space. It is creating its own space. This is inflation theory, and it solves a huge problem. If the universe started as a tiny dense point, a singularity, and then exploded outward, why is the universe so smooth? Why is the temperature the same everywhere? If I pour hot coffee into a cold room, it takes time for the heat to spread. But the universe is uniform. Everywhere we look, the temperature is 2.7 Kelvin. This suggests that just for a tiny fraction of a second after the Big Bang, the universe expanded faster than light, much faster. It stretched out any wrinkles. It smoothed everything. And here is the terrifying part. Inflation might not have stopped everywhere. Maybe our universe is just a bubble where inflation stopped. A calm patch in a chaotic, boiling ocean of eternal inflation. Outside our bubble, space is still expanding exponentially forever, creating new bubble. New universes, infinite universes. But our universe, the one we can see, the one we can measure, it is finite. It is a bubble. It has a specific size, a specific age, a specific end. And the reason we think it is infinite is because we can only see a tiny piece of the curve. Like an ant on a basketball, the ant thinks the world is flat. But if he walks far enough, he realizes he is on a sphere. We are ants on a cosmic basketball. But there is one final mind-bending possibility, one that makes the entire concept of size irrelevant. What if the 3D universe is an illusion? What if we are actually 2D? Let's talk about a hologram. You've seen them on credit cards. It's a flat 2D image, but if you turn it, it looks 3D. It has depth, but the depth is an illusion. The information is all stored on a 2D surface. Now look at the universe around you. It looks 3D. You can move up, down, left, right, forward, back. But what if the universe is a hologram? This is the holographic principle, and it is not science fiction. It comes from studying black holes. When matter falls into a black hole, it disappears. But the information about that matter, its quantum state, cannot be destroyed. That is a fundamental rule of physics. So where does it go? It gets smeared on the surface of the black hole like stickers on a balloon. The information is stored on the 2D surface area of the event horizon, not in the 3D volume inside. Think about a can of soup. The label on the outside tells you exactly what is inside. You don't need to open the can to know it contains tomato soup. The 2D surface describes the 3D volume perfectly. Now apply this to the entire universe. The holographic principle suggests that all the information in our 3D universe, every star, every galaxy, every thought in your brain, might actually be encoded on a distant 2D surface, a cosmic horizon. If this is true, then the 3D spa, say, we think we live in, is just a projection, a shadow. And if it is a projection, then the infinity of space is just a mathematical trick. The universe isn't infinite. It has a specific amount of information, a specific resolution, a specific number of bits. It is finite. It is bounded by a horizon. It is a cosmic hard drive, and hard drives get full, which leads to the final terrifying conclusion. So where does this leave us? Trapped in a box, living on a donut, a smudge on a hologram. It sounds claustrophobic. It sounds like a prison. But let me flip that for you. If the universe were infinite, truly physically endless, then you would mean nothing. Remember the monkey? In an infinite universe, there are infinite versions of you, infinite Earths, infinite mothers, infinite first kisses. You become a commodity, a cheap copy, a rounding error in a spreadsheet that never ends. But if the universe is finite, if the deck of cards is only shuffled once, then you are rare. You are not a copy. You are a limited edition, a distinct, unrepeatable arrangement of atoms in a finite amount of space and time. The darkness of the night sky isn't a void. It is a velvet curtain around a jewel box. It tells us that the light is special because it is scarce. We are rare, we are fragile, and we are trapped in this beautiful finite bubble together. So the next time you look up and see the dark, don't be afraid of the nothingness. Be grateful for the edge, because without limits, nothing has shape. Without an end, there is no story. And I want to know what you think. Is a finite universe comforting, or does it make you feel trapped? Tell me in the comments. And if you want to break your brain even more, click this video next, because if space is finite, what about time?